last week. Are you looking for?
Yeah.
Oh yeah, there is. So we were talking about rational functions, right? We had looked at how do we simplify rational expressions, functions, expressions. Let's just kind of finish up the one we had started, and then we'll push on and we'll look at how do we multiply and divide rational expressions. And what you find is it doesn't really add much to what we already did. So this is the one we were looking at, right? We started off, looked a little tougher, a little more factoring to do. What are the steps we go through? Quick review. So we want to factor everything that can be factored in the numerator and denominator. Let's get all phones away, please. We want to, if we have monomial factors, those are easy to divide, right? We know how to do that. We just use properties of exponents. We're going to eliminate, cancel all common factors. But the thing that's really crucial and that's easy to forget is we have to exclude any zeros of the denominator that ever occur. But, before canceling, are there any zeros of the denominator? And those have to be excluded. So we factored this thing. We're able to factor out a GCF from the top and the bottom. And I think we had just left off where we had fully factored. We'd factored the top and the bottom. We had these trinomials that we had to factor by grouping. And we did that. And we ended up here. Okay, so now tell me, what values of x do I have to exclude? What's one value of x I must exclude from my domain? Got to exclude 5. Yeah, right there, right? X can't equal 5. What else? Negative 1/2. Good, because that's the zero of this factor, right? Anything else? 0. Yeah. That monomial factor, 2x squared equals 0 when x equals 0, right? And remember, anytime we have a monomial factor, the zeros are always just going to be 0, right? The single 0 is going to be 0 from that one. So those are the 3 values we have to exclude. Okay, now what do we get to do? We get to cancel, right? So now we're going to write the simplified form of this. We can cancel those common factors. How about over here with our monomials? What cancels? Actually, the whole thing, doesn't it? In this case, right? We can cancel the entire 2x squared. And so our final answer just looks like x plus 5 over x minus 5. So if I were to look at the graph, what does that mean? If I were to look at the graph of this very complicated rational function that we started with, what we'd find is that it would look exactly like this much, much simpler function, with the one difference being that these values of x would be excluded. So there would be holes in the function. Like if I tried to look at the graph of the function at x equals 0, there would be a 1 pixel, 1 point that would be missing from the function because that had to be excluded. At x equals negative 1/2, same thing would happen. Let's just demonstrate that real quick, like in Desmos. I just want to make sure that you got this 100%. So if we go into Desmos and graph this thing, okay, so all that stuff, there's the top polynomial. Okay, so there's the function, right? So what do we see if we look at this graph? Obviously, at 5, the function's undefined, right? I've got this vertical asymptote there. We'll talk more about those later. But if I try to evaluate the function at 5, it tells me it's undefined, right? Okay, got that. But also, if we try to graph this function or try to evaluate this function at like 0, it tells us, even though you can't tell from the graph, it looks like the function goes through that point. It doesn't. It's undefined there. There's a hole in the function. If I go to 0, look at that. There's a little hole there. Notice that the point becomes an open point. It's not filled in. If I can, right there. See that? Everybody see that? It's hard to see. But it's an open point, and it tells me it's undefined. And if I try to go to negative 1/2, I probably won't be able to hit that one exactly. I'll try. There it is, right there. Same thing, right? The function's undefined at negative 0.5. So I have holes in the function there. They're not very obvious when I graph this thing. If I were to draw a sketch, I would just put, holes that were obvious at those places on the function. And when we graph these things, we'll pay more attention to that later when we focus on graphing rational expressions. Okay, how we doing? 1 to 5. That all make sense? Okay, we're getting there. All right. So when we multiply, it doesn't do anything differently. When we multiply rational expressions, remember that when we multiply fractions, we just multiply straight across, right? So all I do is I just make one big bar, and everything that's being multiplied in the top goes in the numerator. All the denominators that are being multiplied go in the denominator, and then I just simplify it just like I've been doing, right? So this top one's pretty simple because I've only got monomials that I'm multiplying, right? What's this going to give me? And this is one we could have done a long time ago, right? This isn't anything really all that new to us. What am I going to get in my numerator when I multiply straight across using properties of exponents? I'm going to get 60. X to what power? X to the 5th. Good. I multiply those like bases, so I add the exponents. Y to what power?
7.
The 7th. Okay. On the bottom, I get 36. X to the squared. Y to the 4th. Okay. So now it's factored, isn't it? I mean, there's nothing to do here. It is factored. The only factors I have that have variables in them are x to some power and y to some power. So then what values of variables do I have to exclude here? For x, what value would have to be excluded?
0.
0. Yeah, because look, I've got an x squared in the bottom. So x can't equal 0. I can't divide by 0. So x can't equal 0. Anything else I need to exclude? Remember, I can't divide by 0. Is there any other value of a variable that would force me to divide by 0? Y. Yeah, look, y can't be 0 either, right? Because I've got a y to the 4th on the bottom. So those are my two exclusions. Neither x nor y can equal 0. Okay, now that I've got my exclusion list, I can cancel and simplify this thing. So what's that going to give me then? If I look at my numerical part of the fraction, 60 over 36 reduces to what?
5 over 3.
5 over 3. I can divide both by 12. So I get 5 on the top and 3 on the bottom. How about the x's? Yeah, okay, I'm going to get an x cubed on the top, right? And how about the y's? Yeah. Y cubed on the top. So that's my answer. I'm done. Okay, give me thumbs. How we doing? Okay. Let's look at another one. How about this guy? Well, it looks complicated because I'm multiplying, but remember, all I'm doing is just factoring the top and the bottom. I could even really just do this, right? I could just make this one big division bar. And just do that. That's all the multiplication does. I multiply straight across. So on the top, I get the product of all the factors that I had in the numerator, right? Bottom, I just get the product of all the factors that were in the denominator. And I can go further. Those are not completely factored, are they? So what could I do with this guy? You take out a 4x, leaving behind x minus 1. Okay, good. So that's what all this stuff is giving me. Right? How about this other factor? Does that break apart? What's that break up into?
X squared plus.
This guy.
X.
X plus 3, X minus 2.
There you go. X plus 3, x minus 2. Right? So that's what all that breaks up into. Okay, how about this guy here? Anything I can do? Take a 2 out, and that leaves behind x squared plus minus 3. So what's that break up into?
X plus 3, X minus 1.
X plus 3, x minus 1. Good. Okay, and then finally, how about this one?
4x.
Pull out 4x, and what's left behind?
X. Plus 2x. Wait, no, X plus 2, yeah.
X plus 2. Okay, I like it. Everybody agree? Everybody see that? Okay, so, I mean, now we've got this thing completely factored. We need to list our exclusions. What values need to be omitted from the domain?
Negative 2.
-2,
0.
0,
1.
1,
Negative 3.
-3. There's our exclusions. Now what? To simplify, that's our answer, but it's not simplified. Cancel, yeah. So cancel like factors. So let's see, there's a 4x that cancels. I've got an x plus 3,
X minus 1.
x minus 1. Okay, good. So then we end up with our final answer. Just looks like what's left on top? Just x minus 2. And on bottom,
2x plus 4.
2. And then we'll just leave it factored. 2 times the quantity x plus 2. We'll leave it factored. How come we leave it factored? Because usually the stuff we're going to do with this need it to be factored. Typically what we're going to do, like when we get to the point where we're solving equations, it's probably going to be equal to 0, and so we're going to have to apply the zero product property, so we need it to be factored. Right? So just leave it factored. Okay? How we doing? 1 to 5. Okay. All right. That's good. We're getting there. Let's just look at, okay, so division. This is another example. Division doesn't really change things very much, right? Because what's our rule? Going back to what you know about just fractions, about doing arithmetic with fractions. How do you divide by a fraction? What do you do? Okay, good. You flip and multiply, right? You multiply by the reciprocal, okay? So that's all we're going to do to divide a fraction. Remember that we're just multiplying by the reciprocal, right, of the denominator. Now, in this case, it's what do they mean by denominator? Well, they mean the thing we're dividing by. The other way that this could be written as this first rational expression divided by the second one. So the second one would show up on the bottom of a great big division bar, right? We get fraction divided by fraction. Either way, write it that way or this way, we're going to multiply by the reciprocal of this second factor or the second rational expression, right? Okay, but here's the part that you have to be careful about when you divide. You can never divide by 0. So you have to look at the exclusions before and after you flip the denominator, the second expression, right? So anytime, here's how you have to kind of think about that. Anytime there's a factor in the denominator, and any step during the process, you have to exclude all the zeros of that denominator, right? So you're going to get an extra layer of exclusions when you're doing a division problem that you didn't have with multiplication. If we look at the previous example, we only had to worry about nothing ever got flipped. And so the factors in the denominator started in the denominator and ended in the denominator, right? But when we're dividing, we're going to flip this bottom fraction so that the factors that start off in the denominator don't end up there, right? They end up in the numerator. But because they were there to begin with, they have to be excluded also, right? Okay, so let's do this then, right? So we've got, I'm going to write this a little differently. I'm going to write it as one big fraction. I think that's better personally, but it's up to you. I think it's clearer when you write it that way. So this is equal to, before we do anything, we've got this rational expression on top. Divided by the stuff that's in the bottom, which is that stuff, right? So it's divided by the other fraction. Everybody see that? So this is called a complex fraction. I've got fractions divided by fractions. So what do you think our first step is? Okay, but before we do anything, eventually we're going to, but what do we need to do first, do you think? Factor everything. Yep, we're going to factor everything. Good. Okay, so equals, I'm going to have enough room here, but hopefully. So what is, if we look at the blue fraction up here, how does the numerator factor?
Take out 2a squared.
Times,
A minus 6.
okay, good. Denominator,
It's -6 and 2.
a minus 6 and a plus 2, I'm hearing? Okay. So now already we've got to start our exclusion list, right? Because we've got some factors in a denominator. This is a denominator of a fraction, right? So we'll go down here and start our list. X cannot equal what? 6 or -2. Okay. Now how about the fraction that's in the denominator? What do we get if I factor the top of that fraction?
8a squared.
Did I write that correctly? Yeah, I did. Okay. 8a squared times what?
3 minus
Minus a. Okay. Divided by, on the bottom,
a.
okay, a minus 5,
A plus 3.
a
Minus 3.
minus 3. Okay, so what other values do we have to exclude?
+5.
Positive 5 and positive 3. Everybody see that? Because those are in a denominator, right? Okay, so now we're going to go ahead, now that we've got everything factored, we flip and multiply by the denominator, right? So what's that give us then? Then we get, on the top, we've already got the blue one factored, right? So we get 2a squared times a minus 6 divided by a minus 6 times a plus 2, right? Times the reciprocal of the red one. So what's going to go on top? times,
A minus three.
okay, on the bottom.
A squared times quantity minus
Okay, so now what? Do I need to, what values do I have to add to my list?
0.
0, and then I've already got 3, don't I? So that one's already taken care of. But this guy right here means I've got to add 0 to my list. Everybody get that? Okay. You see the extra step there? Even though a minus 5 times a minus 3 ended up in the numerator, because they were in the denominator before I flipped, I had to exclude the 5 and the 3 anyway. Okay? Give me thumbs on that. Everybody get that? Okay. All right, so now this just becomes a regular old multiplication problem, and all I do is just extend the division bar, and now I've got more factors in the top and more factors in the bottom, but I just do what I always do. I've already got all my exclusions, so now I get to cancel stuff. So what cancels? A minus 6 cancels. What else? So is there a little bit of confusion about how to deal with the 2a squared over the 8a squared? Okay, so really there's 2 parts of each of those. I have some constant times the factor a squared. The 2 is really just a constant factor. It's not truly connected to the a squared. It's just being multiplied by the a squared. But the a squared is a monomial factor by itself that I can cancel. Everybody see that? The a squareds cancel. Now what could I do to the 2 over 8? Yeah, I just reduced that, right? So that just becomes 1 over 4. Okay, it looks like the a plus 2 stays there. Now, how about this?
Can't you just like multiply by 1 or
Yeah, how do I deal with that? A minus 3 divided by 3 minus a. Good, okay, so I could factor like a negative 1 out of the 3 minus a, and that's equivalent to saying minus a minus 3, right? Okay, but you don't even have to do that, right? We could just remember that anytime I'm dividing conjugate factors like that, what does it always simplify to? Negative 1, exactly. So we could just cancel this whole thing and just replace it with a negative 1. Make sense? Okay, so then what do we end up with? Our final answer, we get, on the top, we got a negative a minus 5, right? On the bottom, we get a 4 times a plus 2. And that's all that's left. We just leave it like that. Okay, make sense? Okay, so there's our answer. These are our exclusions. Okay, so what about one like this? This time we won't write them as fraction divided by fraction. We'll just use this division symbol notation so we can see it once each way. So what's our first step going to be here? Say it again. Okay, factor everything first, right? Factor everything we can. Good. So what's that give us? What's our numerator of the first?
X plus 5, x minus 4.
Okay. Divided by,
X plus 7, x minus 6.
good, times, next one, Todd?
X plus 3, x plus 4.
Denominator,
X plus 2, X plus 1.
good. Divided by, how about this guy? Top's done.
Now you have to take out the exclusion of the value.
We will, but we gotta factor it first. In order to know what the exclusions are, we gotta get it factored. So how about this guy?
X plus X plus 1.
Okay. Okay, now, good. Now we've got everything factored, so we can compile our exclusion list here. X cannot equal, throw out some values. What's one thing it can't equal? -7, +6, 4, -1, already have it. -1, already have it. Okay, good. So far, so good. Okay, now what? Got to flip that one, don't I? Dividing by that fraction is equivalent to multiplying by its reciprocal. And so we end up with, let's go ahead and make one big division bar while we're at it. X plus 5 times X minus 4 times the quantity X plus 3 times the quantity X minus 4. What used to be in the denominator goes to the numerator. In our last fraction, on the bottom, got X plus 7 times X minus 6 times X minus 4 times X plus 1. And now that X plus 3 that was in the numerator ends up in the denominator, right? Okay, any new exclusions?
-3.
Yeah, okay, we get one more, don't we? We get this -3. We have to add that to our list. Okay? And now what do we get to do? Cancel. Yeah. So if we cancel stuff, what cancels here?
X plus 7. X minus 4.
Yeah, there we go. Okay.
X plus 1.
X plus 1.
X plus 3.
X plus 3. And so we end up with what's left in the top?
X plus 5. X plus 4.
And in the denominator, X minus 6. Okay. Make sense? Think you got this? Okay. You can work on it. This is the second half, still that first assignment, but this is like the second half of the multiplication and division problem. So work on wrapping that one up. Yeah, you bet.